Assalamualaikum warahmatullahi wabarakatuh. My name is Amrulfalah bin Muhammad Amin. I'll be presenting on Bernoulli's principle. Introduction of the experiment. Bernoulli states that when speed of a moving fluid increases, the pressure within the fluid decreases. The sum of all energy forms in a fluid flowing along a streamline is the same at any 2 points in that path. In a steady flowing, non-viscous, incompressible fluid, this equation is used, whereby P is the fluid static pressure at cross-section, ρ is density of flowing fluid, V is mean velocity of fluid flow at cross-section, and h is the elevation height of the center at cross-section with respect to a datum. For an incompressible fluid flowing in a tube of varying cross-section, the mass flow rate is the same everywhere in the tube. This is stated by the continuity equation, whereby AV is the flow rate. Velocity of fluid is greater in the narrow section. From Bernoulli's equation, it can be derived into this equation by dividing all terms with ρg. Pressure head plus velocity head plus elevation head equals to total head. The total head at any cross-section is constant. This is according to Bernoulli's theorem of fluid flowing through a pipe. The center line of all cross-sections lie on the same horizontal plane, which we may choose as the datum z equals to 0. Therefore, all z values are 0. Hence, this equation. The objective of this experiment is to determine Bernoulli's theorem, which can be applied to a venturi meter consisting of converging portion and diverging cone. Methodology of the experiment. Firstly, the test section is installed with the converging section upstream. Secondly, the outlet flow control valve at the Bernoulli's theorem demonstration unit is gradually opened to allow the volumetric tank of the hydraulic bench to be filled. Water is then allowed to fill in the manometer tubes until all trapped air is removed. Air bleed screw is opened and controlled to get a certain volumetric flow. The screw is retightened when the manometer has reached a suitable height. All manometer tubes connected to the corresponding pressure taps are checked to ensure they are air bubble free. The discharge valve is set to a high measurable flow rate. After the level is stabilized, the water flow rate is measured using volumetric method. The hyperdomic tube connected to manometer H is smoothly slid so that the cross-section of venturi tube at A reached its end. Step 9 is repeated for other cross-sections. The velocity VIB is calculated using Bernoulli's equation. The velocity VIC is calculated using the continuity equation. Finally, the difference between the two calculated velocities can then be determined. So this is the setup of the experiment. Calculations and results. For each cross-section, the velocities are calculated using Bernoulli's equation and continuity equation. Then, the difference between VIB and VIC are calculated. Discussion. The value of total heads were not constant throughout all cross-sections. This may be due to friction, other imperfections, and measurement uncertainties. When the diameter of cross-section decreases, velocities along distribution tube increases. At smallest cross-section, which is C, there was a big pressure difference and it had the highest velocities. Bigger pressure difference caused highest speed of fluid flow. For Bernoulli's equation, as the speed of fluid increases, pressure decreases. Pressure increases when pipe opens out and fluid stagnate. For continuity equation, it is the conservation of mass on a steady flow process through a controlled volume. As the density of water is constant, velocity equals to volumetric flow rate over area. VIC took area of cross-section into consideration, whereby as the area increases, velocity decreases. Overall, VIB are greater than VIC. In conclusion, firstly, it is concluded that the aim to demonstrate Bernoulli's theorem in this experiment is achieved. High velocity of fluid flow results in low pressure, according to Bernoulli. Based on the continuity equation, smaller area results in high velocity. Both equations could be used to determine velocity of fluid flow in manometer. Even though velocity values are not the same for these two different methods, but pattern of the increasing and decreasing at converging and diverging portion is the same. as the velocity increases, total head pressure also increases for both convergent and divergent flow. That is all from me. Thank you very much.